Okay. All right. So we're gonna continue um, with Rustlings. Yeah, we're going through the Rust book and trying to familiarize ourselves with the syntax of the language, so we can build the app that we um, want to build, or we already started previously. Yep. So let's continue from where we left off yesterday. So I think we were looking at enums, right? No, was it enums? I think it was enums. Yep. We actually finished it, but I think there was something that we wanted to check. I probably closed it. I think it was on pattern matching. Enums pattern matching, yeah. But There is another chapter on pattern matching in the Rust book. Let's see if we. Was it chapter 19? Yep. So we. I think it was this. I don't know if it was this one. There was some part yeah, I think it's pattern syntax. And I guess, yep. Yeah. Additional match guards. Additional conditionals with match guards. Yeah. I think, yeah. I remember now. So we left off, we wanted to read about bindings, right? So yesterday we didn't finish this part. So let's do it. It's gonna be a short stream, about an hour. So I don't like this song. Okay, this is better. So how does the add binding work? It's an add operator. So it allows, I think I'm remembering now, recalling this. Allows us to create a variable that holds a value at the same time we're testing that value for a pattern match. So here we want to test that message hello, as a message hello, ID field is within the range 3 up to or equal to 7. Okay, message yeah, then a num with a variant hello that has ID field. So we create a message, an instance of message hello. Yeah, and then we do message. So this is where we use the pattern matching syntax. We destructure this and say ID. We expand this ID at 3 up to or equal to 7. So this would create a variable here. Okay, whereas what's the difference with this one? This doesn't create any variable. Okay. Oh yeah, we can bind it. Then we use the at. I see. All right. Want to test that the message is within the field 37. We also want to bind the value to a variable ID so we can use it in the code. So and then we use that here to print. Okay. This example we print. We print found an ID range 5. Yeah, because it's within that range. By specifying ID at before the range, we capture whatever value matched the range in the variable named ID, while also testing that the value matched the range pattern. In the second arm, where we only have a range specified in the pattern, the code associated with the arm doesn't have a variable that contains the actual value field. Yeah, we haven't saved it in the variable. Okay, so that's it. Um, yeah. So now we can go over. Well, I like to write a small piece of code um, for that to test it. I think we also can get rid of this. Okay, so we can say mm, actually an message, yeah, and then hello, for example. Uh, like 32. Then say I want to use this here. Okay, and then we can try to match this, right? So we can say match and message. Three up to seven. Non-exhaustive. Whatever it is. Right. Okay. I think we see how that works. Let's move on to the next one, which is strings. Now we're gonna have to read about strings. Okay. I think strings should not be. Okay, so we're going to be discussing strings in the context of a collection of collections. They're implemented as collection of bytes. Operations on a string that every collection type has. How do we define a string? New, right? I mean, like, not define, like create a string, yeah. So we define the term, define what a string is. Rust has only one string type in the core language, which is string slice, str. This is usually seen as borrowed from. Yeah. String literals are stored in the program's binary and are therefore string slices. The string type, which is provided by Rust and the library, rather than coded into the language, is growable, mutable, okay. So it says like it's what? Growable, mutable, owned. Yeah, UTF-8 encoded string type. So when we refer to strings in Rust, or when Rusticians refer to string in Rust, they're referring to either the string or the string slice type. They might be referring to either the string or the string slice types, not just one of those types. Okay. So now we're talking about about the string, which is the not the slice, yeah, the actual string. So when we're creating a new string, we use the new what was the name for this kind of, I think it's called an associated function, or is it, yeah. Yeah, a suited function. Many of the operations available with vecti, are available with string as well, because string is actually implemented as a wrapper around the vector of bytes with some extra guarantees, restrictions, and capabilities. Okay, you can also use a string from. Yeah. So, how to grow a string? The push str method. Well, how? Wait. Oh yeah, pushing an entire string to it. Otherwise, if you do push, you're pushing a character, a single character. If you use the plus operator, you are concatenating the strings. I mean, the way that will work is that I think a new string has to be created. S1 has been moved here and can no longer be used. So S3 is S2 concatenated with a reference to S2. Yeah, so a new string is going to have to be created. That's why S1 is moved. Oh, the reason why we used S2 as a reference is because of the nature of the signature of the method. Okay, so it's add. I take self, and then a slice, a strict slice. So that's what's called under the hood when we use the concatenate operator. Oh, come on. Hey, Justus Flugel, how's it going? Yeah, so the concatenate operator is basically calling um add. Okay, what favor would you like that I do for you? The pencil. Click on that pencil on the top left. Oh, this one here. Oh, you need to what? She selects this. Ah, okay. Dark mode, right? Sort of. Okay. Right. It's much better actually. Nice, nice. Okay. Yeah. So yeah, we're doing Rust and well Rust links. Some, I mean, some weeks ago or like months ago actually, I was building a Rust app and then I left it for a bit. So now I'm doing a refresher just to to get the ropes again, and then we go back to the app, right? So just going over Rust links and just glossing over some things that we need to recall how this works again. Yeah. Okay. So yeah, that's for the operator. Okay. Nice. Mm, okay. So we're creating a string from um all of this, right? S1 and reference to S2 and same thing with S3. Yeah, of course S1 is moved, but we're just using references from the other two, so it's okay. Or we can use the format as well. Okay, that's fine. Indexing into strings. Yeah. So we cannot do this, and the reason is because it's. Um, I mean, we saw that strings are implemented as a wrapper on top of a vector, right? So it's bytes. So how do you index on that? So that's why this wouldn't work, which makes sense. So you index how? Okay, string is a wrapper over um, VQ8. Yeah. Okay. Mm. Well, the reason is that strings are UTF-8, yeah, and as such, index by byte would end up on a multi-byte UTF character, yeah, sequence, and you need to be careful with that, yeah, yeah, certainly. So it doesn't allow you to do, or it does allow you. I mean, you can do this. So rather than index using braces to a single number, you can use this with a range. Okay, yeah, pretty standard. Yeah, at least you know what you're doing. You're sure, yeah, or at least you say what you want. It just still knows to be careful or to be cautious when creating string slices. Yeah, it can crash your program. So what? So what is the standard way of? Ah, okay. So you don't want to be working with strings like this. That's what I get from this. I mean, if you want to do that, then you should use chars or like those string slices are fine. Yeah, yeah. So this is basically a string, and then you get the characters from it, and then you do something with it. Like with ASCII, they're always fine. Yeah. You can also even get the bytes. Nice. Multi-byte sequences. Yeah. So this means when you want to manipulate or handle, um, let's say, sequence of characters and move things around and the rest, well, you should convert to characters before you maybe like iterate or do whatever you want to do. Just like something like this, I would imagine. I mean, if you want to play around with it and not exactly like access the, yeah, not exactly access the a particular index, like what you wouldn't go get like the fourth index or something. America Charles, you need to be careful. Yeah. Okay. Yeah. Okay. Like for example, with skin colors in emotes, characters that modify other characters, other chars, chars that modify other chars. And the base character for each emote. Okay. Um, so um, let's play with something. I wanna just play with strings and let's see. Mm, think um, how how again? I think it used to be. I think Mac has this shortcut for getting the emoji thing up. Is it not? Yep. If you want to iterate over graphemes, you want to use Unicode segmentation. Great. Yeah, I think I saw something about graphemes there in the book. Okay, it's just like that. And let's just play with this. Why is there a special way to click this? Okay. Try like an emote that has a different color variant. Okay. Do we have one like that? Yeah, I believe. Maybe. Let's see. What's its face? And I don't think we have that. Yeah, okay, I probably have to copy that from maybe the internet. Um, maybe not an emoji. I said skin tone. Oh yeah. Okay, I can actually copy. Maybe like and you want us to copy another one maybe. Okay. Now so we can do by the way, this is not even like so. It should be we're dealing with a collection, yeah. So um yeah, or actually we can do it like that, right? Yeah, I think we can do it like so. Yeah, it's actually a string type. So um or like maybe item in emojis. Hmm. And then we can first I want to just print what we have there, right? Yeah, I made a small demo. Where did you make it? Okay, you want to paste it here. Okay. So, oh yeah, we cannot iterate over this because string slice, I mean, yeah, it's not an iterator. Oh, I have links disabled here. Hmm. Oh, do I have it? What did I do? What did I do? Oh yeah. Um, should be an channel, I guess. Is it create a dashboard? Um, I, I think it was on moderation, right? Maybe. I don't know now. Like there was something about that I maybe set moderation settings. Hmm. And then chatter permissions. Okay. Show advanced. Probably you mean like this, I guess. Okay. Block hyperlinks. Oh, okay. I don't think I ever said this. Yeah. Okay. I think I should be gone now. Oh. Oh yeah. I think it works. Yeah. Okay. Yeah, cool. But yep. I I didn't enable this for me to see. Well, whatever. No. Okay. 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 Your font in your browser doesn't support the emotes. In the browser? Oh, you mean here? So once it um yeah, so it's in the browser. Okay, yeah. So we do um debug, and then we're doing this emoji.length, and then yeah, so the length is 8, while the chars that we have there is 2. Okay. Yep. Yeah. So if you go, if you had done the chars, I mean, I want to also print the chars, you know. Oh yeah, that's what we did here. So you have a printing line, and then you are printing here. Yeah, a reference to this one, right? I mean, this slice from 0 to 4. Okay, and then you are printing 4 to the end, right? Oh, for the same emote, yeah. And then you have a different one. This is what you mean. Okay. Remember slices use byte indexes. Yeah. Yeah. Byte indexes. So going from 0 to 4 here. And then the other one, the rest. And then you have something different. Something. Yeah. Okay. Yeah. Okay. And then, but when we say chars and count what we have in chars, come on, what we have in chars. Is an iterator, yeah. Yeah. So probably what you mean is that I'm doing something like a for item uh, in these dot chars. Yeah. By the way, I'm also I also have like a split keyboard that I'm just starting to use. So a bit it takes a bit of yeah, yeah, learn how to use it or getting to use it. Yeah. So and then we can do a print line. Can directly do print line item. Yeah. Okay, you mean I have to do this here. That's what you mean, I guess, yeah. Yeah. Okay. But so in the charts it said there were two characters. We don't see anything for the second one, I guess, but it's there. It has to be there because character count is two. But yeah, do you know why? Yeah, don't sprint it twice, of course. Yeah. Okay, but anyway, I think we get the point with strings and indexing strings particularly, right? So I mean, what to pay attention? Yeah, isn't trivial. Yeah, what to pay attention? I mean, uh, in a language like um, I mean Java, for example, it's made to look like it's trivial. Yeah, but obviously it's not. So when you work with strings, you can basically index on the strings directly there, but here you know that you don't want to do that. You have to think twice about it. Yeah. Okay. Cool. And yeah, I think that's it for for strings. Um, yes, you have 16. 2 16-bit code units to represent characters. But does Java really use to represent strings? Jar. Can hold characters in the basic multi-language plane. Requires a good pair. Series in one character. Okay. Oh, come on, I copied it. No. Yeah, I was copying this on the on mobile. Like, but yeah.
UTF-8 is one of the most common and widely used systems for encoding text on computers.
Okay. Okay. Yeah. So I'll check this one out. Um, After now, yeah, I'll check it out. Um, yeah. Okay, but if I think I got the main points of this, and maybe I would move on with doing the exercises they have here. So I guess that would be, yeah. Thanks for sharing the YouTube. I'll check it out. Um, Maybe after the stream. So we fix the compiler error without changing the. This is the rustling program. Fix the compiler error without changing the function signature. What? And its current favorite color. It's returning an on string, but this is a string slice. So what we want to do here is what, to string, is it not? Yeah, I guess. Okay. This is compiler error in the main function without changing this function. So we don't touch this one. It's a color word. Here I created a string. We shouldn't change this line at all. It's a color word. It should take a string slice. Okay, that should be this. Oh, come on! I thought they were gonna give us something like much more difficult. Like, anyway, it's trim me. This gives you a string slice. Remove white space from both ends of a string. So it should return input dot both ends. We should have trim, I guess. Yeah, what does trim return? Returns a string slice with lead non-trivial removed. Yeah, it's a string slice that gives you back. Okay, so that takes care of that. Compose me. Add world to this string. There are multiple ways to do this. Add world. That would be. I mean, we can do dot add. Oh no, it's not a string, right? Okay. Can we do string from? Or that would be literal, right? So what we can do, input dot to string. Yeah, and then dot. So it says there are multiple ways to do it. Yeah, I can already think of why can't we do add? This is an own string. Um, why can't we do add? Yeah, I thought about using that one, but why can't I use add if I already have uh it just gives me an own string. Why? Alternative use format. Yes. And we can also use a we can also even do a vector if we wanted, but add is on. I mean, add takes self and then a string slice. So where do I get to use add? It comes from the add trait, and so if we check the language reference, or standard, right? What's it called? Standard documentation. Is it not? Yeah. Yeah. Yep. Okay. So the add trait. And it's so if I were to check string, the string type, but using plus it already calls that function. Yes, but am I not? So you should prefer to just write that. So I agree. However, when I think of the concatenate operator, like this plus operator, it it makes me think of two things at the same time. Ah, yes, this top. Where am I clicking on top right? Okay, yeah, here. Okay, okay, okay. I'm gonna always set it to the IE theme. Yeah, right. Um. Okay, yeah. I'm just trying to. Yeah, I was saying that when I use the plus or the concatenate operator, it always makes me think of two things at the same time, and like I always have to overthink it. So much more comfortable. Okay, I guess coming from one language maybe, but yeah. But I just wanted to know why where I have access to add. Why is it not on string? Is it not? So this is string now. I think it should be under. What's it called now? It should be under. You can just use push. Yeah, yeah. But push will be on just one character, right? Um, yeah, push is a character. I think we'll use push string. Yeah, yeah, yeah. But where is add? I just want to understand how this part is, how the trait is used in string, or maybe it comes from something else that. Did you see the add method? Is it here? No, it's not here. You are referring to. Okay. Add. Where is this? It's in string. I was checking this a method. Scroll down to the on that traits, right? Is it trait? Okay, I think I was in trait implementations. Okay, add this. Yep. Okay. Okay. Makes sense. Um. But why? But you cannot use it directly. So implements the plus operator for concatenating strings. This consumes the string, but this is how you use it. You cannot call add directly. If you import the add trait, okay. Let's let's do that because I want to see how this ties in. Oh wait, we were here. Okay, so if I do, yeah. So assume I do that here instead of the top. Yeah, bring this up, and then I say input dot add. Was that actually give you a quick switch to import it? It should already be here. It doesn't. Is it because I do that here? Okay, that's imported. Says there's no reference. No, the location. Yeah, exactly. I also know that it should not, but I was not sure why we don't. Oh wait, hold on. Is it because this is? Oh yeah, I have to say to string. Right. Okay. Interesting. Okay. Right. So the trait has to be the trait has to be brought into scope first before we can use it. Yeah. Okay. Okay. Yeah. Okay. Thanks for clarifying that part. Um, yeah. So with this, we can. I want to add world to it. So yeah, we still can't do the push because we push is yeah. Okay. So we do push string and then we say world one way. Another we can do is to say input plus world, right? Another we can do is to say um, format. I think is what you're referring to, yeah. Input and then we just say world. Okay. Yeah, this is going to return a string. So we for this one we would have to do and this is we'll probably have to do to string for this one if we were to do this. I guess. But anyway, I think no, you don't need that. Cannot add str. So I'm saying if I do this, I think this one was fine, but this not. And it says, yeah, cannot add string slice to string slice. String concatenation requires an. Oh, yeah, yep. Okay, I remember. So add takes self, which is a string first. Yep, yep. And then the other one can be a will be a reference, right? So yeah, okay, right. Yep, okay. Replace me. Replace cars in the string with balloons. Uh, input. Yeah, there is replace. How does this replaces all matches of a pattern with another, and it's from to. From is a pattern. Yeah. Again, how this works is like from the example. All right. So that's just a pattern. Okay. So um, cars. Yep. With balloons. I didn't check what replace returns, but I guess it's not. Oh, it's a string. Okay. Okay, so I guess that's it for this one. Okay. Calls of this function should be replaced with calls of string slice or string. So we have placeholder, we have string slice, and we have string. A bunch of values. A bunch of values. Some are string, some are string slice. Our task here is to replace placeholder with either string slice or string. Yeah, okay. Depending on what you think the value is. So placeholder. Oh yeah. This should take a string slice. I think it's no. How do you even wait? Hold on. Okay, yeah. So it's string slice, and then this. To string, this is string. This here is also string. This is to owned, also a string. But I guess they aren't actually equivalent. Um, how do you mean? How do you mean? So you have compose me. which is a string slice. We take a string slice and input a world, and it gives you a string. Which one are you referring to? Are you referring to the example? Compare the top and bottom one. Okay, this one and the bottom compose me. Okay, I see what you mean. Okay, they aren't exactly the same. So this, when you do to string, which is, I mean, the bottom one here is what we do when we use add, yeah, and I guess what you're showing here is the compilation that happens, right? Yeah. They generate different assembly, yeah. Nice. And but this one here, format, press input that. Uh, do we also see what other detail is available for us to? I mean, are you so? Yeah, they're not exactly the same. Yes, is one more optimized? What do we? How many lines? This is around. Okay, cache this. This is just about caching. The diff on the right compares the two. Right. But what am I looking at on the right? Which is okay, left is the yeah, the one on top, of course, and this is the one under, yeah. Just saying that they might do the same thing, but the format and add is not actually generated for the assembly. Yeah. So, I mean, um, but it's I agreed, but is it like there is any kind of optimization that one has to worry about? I wouldn't think so, right? So I guess it would be negligible in this case. Yeah. So it's given that they don't generate the same thing. I guess. Yeah, they're both internally different. Yeah. I mean that part is clear. Yeah. Functionality doesn't matter. Okay. So yeah, but this is a nice tool. Actually, I didn't. I think I've used this before. Seen this, and it's just for Rust, right? Yeah. What's the? Oh wait, no. Yep. It's Rust Gold bot. Okay. Yes. You can put that. Oh, not just for Rust, but it's called. Okay. Oh, come on! Stop saving this thing. Click Rust on the top left. No. You can change the language to another language. Yeah. Okay. Okay. Where is where do you change the language? Oh, Rust. Okay. Yeah. And then where's the mode that you never liked the light mode? I didn't see it, but I guess yeah. Yeah, I saw this. Yeah, I can change it from here. Um, but yeah, I think we're done with this one. So we can maybe I should probably next time I'll just change my computer to Oh, stop saving this stuff. More settings. Where do you see more? Oh yeah. Doesn't have these fonts. This is fonts, you know. It doesn't have dark mode, does it? Is it coloring? Yeah. Oh, dark. Yeah. Okay. Cool. You know, I cannot exit this. This tool has locked locked it on safe. Like, um, how often do you want to save sites? No, I don't want to save. So Arc browser has this command S to for you to toggle the side navigation for you to view other stuff. But this is it's having save. Yeah, I don't want to save. I guess I would open the new browser window in this case. Yep. Okay. All right. So let's see what we were doing with this one. Yep. So what's this one? To owned. Uh, this is. I said this was string. What function takes zero argument, but one was supplied? What do you mean? Oh, I think we probably didn't save this yet. Yep. Okay. And this one here, into. Uh, what does into do? I remember there was into and from. These are traits themselves. Um, into tries to target the type that we are sending this into, I guess. So if this is a string, it should it just target that, right? But why wouldn't this also work if I target string slice? Would it? It would. Yep. Okay. That's because of how into works. Yeah, and then format returns a string. So this would also be string. Yep. And then indexing now. Okay, let's see if we learned anything. When this is byte indexing, not character indexing. Character indexing can be done using chars and end, then the index. Okay, so we need we are getting a string, we're creating a string from a literal and then getting the slice of it from 0 to 1, and it's byte indexing. Okay, yeah, so it's string slice we need to use here. Okay, so I mean, I want to run this. I want to see what we even get from this. I mean, byte indexing. We should get the actual values as they look like numeric values. Yeah. So these ones, this would be yeah. This is, trim gives us. I think trim gives us a slice, right? Yeah, the ASCII chars. Yeah. He said, well, all ABC are all 1 byte. Yeah. Since the other kick charts. Yep. So what you mean is 0 to 1. Um, is to just return A. Oh, yeah, of course I don't have that. So I can just do a print maybe or debug which one. Why? Oh yeah. Why won't, okay, this won't work, right? Maybe just like let val be that, yeah. And then I can say what do you want? Is it? Size. Yeah. The size for values of type is cannot be determined at compile time. So what? So I'm trying to get a slice. Why? What? What's Oh, I need a reference. Okay. Okay. Then now. Why does it work like this? Why does it work like this? What? Like clear everything. How do I get a new one? I don't need all of this. Why? Oh, come on, get rid of whatever. So, um, I have, I have, um, I have memory location that has, I have ABC, right? So if I have A, B, it was ABC can just clear everything in hamburger. And, oh, by the way, you want dark mode? Did they have it here? Theme. Yep. Okay. Cool. Okay. So we can clear everything with hamburger on the top left menu. Reset canvas. I guess. Okay. Yep. Give me a second. Now have a good answer. Okay. Nice. Okay. Um, wait, no. Yep. Don't do that. Come on. Yep. Okay. I probably just needed to do this. Right. You did that one a year ago. Okay. We should have copied it into link. Oh, so I probably didn't have that. Oh yeah. Nope. Come on. What? um, what is this? Is this character here or what? Like missing the H at the start? Oh, okay. Yep. And yeah, there we go. Okay. Right. Okay. So you have a string slice, and then you have the data on the stack, the pointer to the start of the string slice data, right? You have a length of that, for example, is 3, okay? And then what? This is T. What is T? Is it a generic type or what is this? And then, yeah, the type, okay, yeah. Yeah, okay. And then the heap or the segment, yeah, somewhere in memory, yeah, could even be on the stack if part of another type where the size is not a compile type. Okay, and then cast it to string, like using a of wait and n. Okay, all right. And then, so this part could be, I mean, normally on the heap, but you're saying on the stack, yeah, because if it's a type that can be compiled, yeah, at compile time, yeah, oh no, not compile time. And then you have memory location. It has these values, for example, yeah, of the data. Okay, so okay, oh yeah, so if the length is 3, you have something like this, and then the pointer points to the start of this memory location, and this is kept in the stack. Yeah, okay, and hmm, but what about the okay, right? No, wait. So this is supposed to be about um, string or string slice indexing, right? This is about the indexing, right? Yeah. And if we want to access the zeroth element of this string, in this case, we'll be accessing this one here, right? Yeah. And this is not character indexing. This is byte indexing. If you index it, you just create a new part on the top here with the same pointer, just with a length of 1. Right. Okay. But then what did they mean when they say, so when they say bytes index in the book when we were looking at that. Let me go back there. That the pointer points to the same underlying string data. Okay. So that the pointer points to the underlying string data. What if you have if we have so if we take the okay and not characters. So if we take the case of the emotes that we talked about, characters can be anywhere from 1 to 4 bytes long. So I think this example in the escalate draw, yes, it works, but it works for characters. So take the case where what we have here would be what we start here would be the emotes. So A has a length of 1 byte, for example. Yes. When you say A, what is A here? Okay, yeah. But the emote has a length of 4 bytes, meaning that it is stored across at the underlying memory location. What we stored there. Okay. Yeah. Okay. Right. Okay. So I think that's the thing. Yeah. So it's stored across. Yeah. It's so it's not just gonna be on the zeroth index, for example. It's gonna of course span across um multiple. If it's 4, it will span across multiple. So by the time you try to access the zeroth index, you're only getting a part of it, right? And then that would break your program. But when it's um yeah, because it's spreads across, you cannot do that. Okay. 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 I think that makes sense. So if I check this, I mean, sometimes you have to refresh on this topics. If I go back to where was this again? We're doing this, yeah, here. Yeah. So again, accessing the zeroth. I mean, um, this is 0 2. Yeah, this exactly is the zeroth index basically. Yeah, with length 1. So it's fine. Since exactly since 1 byte long, and if we were doing the emote, then like what we saw now would make sense because we would get something different from what we expect to get. Okay, so again, it's the underlying yeah, I mean it's called string, but the underlying data is not exactly string. Like it's not a string literal, right? So it's bytes data that we store there. Actually, that's it. I think coming from a different language, then it you have to grasp what this means. I wouldn't call this string. I mean, since coming from a different language, it's basically just vector, right? It's that's what it is. You're storing um, you're storing byte data, writing byte data in the memory location, right, and then accessing that or indexing on that. That's it. So yeah, there's not really a difference. Yeah, exactly. So try inserting an emote at the start. At the start, well, if it is chars and bytes, there's not really a difference. Okay. So yeah, you mean like here, right? So let's try to do that. Oh, come on, come on. Yep. Okay. I still haven't figured out why when you do I normally click this the wrong way? Okay, good. All data is bytes. Yeah. Of course. All data is bytes. Yes. When we say strings, we are not being real about it. Okay. Calderon. Of course. Panicked. Yeah. Makes sense. Makes sense. I think that the this thing we saw on the escalate draw, I think it makes it a lot. I mean, yeah, it makes it a lot visual and it makes it easier to grasp this part. Yeah, since the string slice, my text on the right. Yeah, since the string slice is sized. Do you mean sized or there's something this bang before the size? Yeah, we need to have a reference to actually use it. Yeah, okay, not sized. Yeah, aha. So that's the thing we saw when we try to use that's the thing we saw when we couldn't do this here, right? Yep. Yeah, that's the thing we saw here. Since it's not sized, yeah, the size value for type string slice cannot be known. Yeah, at compile time. Why? Okay, it's growable. Okay. Yeah. Okay. Um, we need to have since string slice is not sized. We need to have a reference to actually use it in any way. Hmm. We can store it on the stack. Since if we want to store it on the stack, we need to know its size at compile time. Okay, right. Okay, in Rust, a reference to a generic type to a dynamically sized types that are not sized is always a fat pointer. By fat pointer, you mean a smart pointer, which is done with the din. I think that's what you mean, right? Yeah. Yeah, it's done with a fat pointer, so it stores the length. No, fat pointer equals pointer larger than the pointer of the width of the system. Yeah, but that's what a smart pointer is, right? I think there was this chapter on come on smart pointers. Uh, where is it? Manage memory in some way. Pointer larger than the width of the system. Okay. Fat pointers just store additional data with the main pointer. There's no fat pointer here. Like here, the size of the data it's pointing to. Okay. So let me um okay. Let's see this one that you sent. No, where's it? Oh, come on. Yeah, okay, here. Pointy. Raw pointer and reference types in rows can be thought of as multiple parts. Data pointer that contains memory address of the value and some metadata. Right. Okay. Size trait as well as external types. Pointers are said to be thin. thin. Metadata is zero size. This type is this. Pointers numerically size types are said to be wide or fat. Right, this is what you mean. They have non-zero sized metadata. Hmm. Okay. For statically sized types, yeah, the ones we know about, pointers are said to be thin, and they have unit type for metadata. Hmm. Pointers to dynamically sized types are said to be wide or fat. They have non-zero size metadata. For structs, whose last field is a dynamically sized type, metadata is the metadata for the last field. Okay, and then the one that concerns us for the um I mean, what's this called? Is it string? Is it string slice in this case? Because I guess the string type would be like the capital string. This this without the ampersand in front. Well, what do you call it? Is this string slice? Is it still a slice? I guess so. For the string slice type, metadata is the length in bytes. Just saying. Okay. Like okay. Or string slice. Yeah, I think string slice. Yeah, works. For the string slice type, metadata is the length in bytes as u size. Yeah, because we cannot know hmm, length in bytes as u size. And the reason we cannot know is because it's growable. I mean, it's also because it's growable. Is that not just it? Like, if we want to simplify the whole thing, this whole thing, we only know for a concrete instantiation of the type what length it is. Yeah, we don't know for other values. Yeah. Okay. I think I recall that they were talking about dynamically sized types somewhere in the book, but I mean when I was reading it previously, but yeah, I think we'll come back to it. But let me finish this thing on the escalate draw. Yeah, yeah. So string slice is a non-sized or unsized type, so we don't know how big it is in memory. We don't know where it ends. It just represents some UTF-8 data which can be interpreted as a bunch of characters. Yep. Okay. I think it's quite confusing. I mean, for someone who just comes into the language to, when you say string, yep, you start to think in terms of the literals or the literal per se. Yeah, but anyway, it this I would call this vector. Like I would just leave it as vector, and there will be no need. But I think they needed some other type to implement the constraints that have to be on a string. So yeah, manage allocation of some UTF-8 data that can shrink or grow. That's the summary of it. internally manages internally manages a string slice. Yep. Aha. Yep. Okay. Yeah. So the string type itself is a managed allocation of some UTF-8 data that can shrink or grow. It internally manages a string slice for that to do. Aha. I guess so you mean like here. It's like a bunch of yeah, so extra bunch of empty spaces for future usage up to capacity. Yeah. But this doesn't also have to be contiguous memory locations, right? I mean, technically. But anyway, string is like string slice, yeah. Except it also has a capacity and is able to dynamically allocate, yep, memory. This means it can grow its allocation if necessary and then update its internal pointer, right? It also means we can append to it since it is able to grow via realloc mem. This these ones are these actual methods in Rust realloc. Do we have that? Is that what it's called, or it's from another language? Like, oh, we do have realloc. Okay, okay, allocates memory. Okay, mem mem copy. Is that it? This in practice may move the allocation depending on if the string has enough capacity left for new data. Mem copy, yeah. And if the allocator has enough space free after the current allocation, right? Then the line allocation still is a string slice and contains some UTF-8 data. Okay. I'm gonna watch that YouTube video, definitely. So let me bookmark it so I don't lose it. And then this is again the stack, the pointer to the start of current allocation for string slice data, length of the current, that is 3. Yeah. Wait, come on. Like so. Okay. A little bit above what is displaying. Oh. Okay. So this is the string slice. Which is controlled by string. I mean internally, yep. By string. Yeah, which we do not know how big it's going to be. It's because it's dynamically sized. And that's why it has to be with a reference, because we're using a fat pointer for this one. And then here, well, string slice is dynamically sized. The reference to it is of a known type. Yep. And then string is this one now, right? And then here, okay, pointer to the start of the string slice data, length of the string slice, all of these bunch of empty space, feature usage up to capacity, and then the type. Okay, and size. This is just showing how external string slice can point to a string's data. Okay, how an external string slice can point to a string's data. Okay, the underlying allocation of string is still being a string slice. Yeah, also means we can build a reference to it, a string slice. This only works as long as the string is not modified, since any modification may move the allocation somewhere else. And then the string size is becoming dangly pointer. Rust's aliasing rules prevent us from actually having mutable and immutable access at the same time, which prevents exerting error. Okay. The underlying allocation is still a string size and contains some, yeah. Okay. And then other pointers to string size. Okay. What's this? Oh, I think um this is beyond strings right now, right? But this can point to string slice. That's what you mean here. Arc. Okay. I guess this is beyond scope right now. Yeah. This is just showing a arc, string slice. Okay. A smart pointer. I recall that uh yeah, yeah, the rightmost one, yeah. I recall also for we had this box tin as well that was being used also as a smart pointer. Yeah. Okay. Yeah, so I guess we have that one. Yeah, box is not a smart pointer. Just allocates on the heap. How is box not a smart pointer? Um, I think how was that? What was the syntax of that? It's not box, din and something, right? It's a okay, box din trait, and then the trait says a smart pointer. Wait, okay. Smart pointer that allocates data on the heap. This is box this. It's the simplest smart pointer. Owns its data and freezes when it goes out of scope. In trait. Okay. You said box of a generic type is not a smart pointer. Box just allocates on the heap. That's instead of the stack, you mean, yeah. But box is just a normal pointer that owns its allocation. I mean, normally the pointer would be on the stack, right? So it can follow to memory location, but um, I think in this case, this is living on the heap. Is that not the thing with the smart pointer? So it can, um, wait, let's even go to where we have, if you define it as different type in Rust, that acts like it's a pointer and manages something, you can think of box as a smart pointer. Yeah, I think there was this chapter on that I was looking at earlier. Yeah, I think it was probably. Oh, stop highlighting like this. I don't like how it looks. Okay, yep. Pointer in. If you think of smart pointers as doing actual memory management, like references counting, which box doesn't do. Right. Okay, that's what you mean. If I think of a smart pointer, I think of arc and RC. Okay. Yeah. But I think when they were introducing smart pointers in this book, I think that was when let's see, a pointer is a general concept for a variable that contains an address in memory. This address refers to or points at some other data. The most common kind of pointer in Rust. Uh, the most common kind of pointer in Rust is a reference, which we learned about before. References are indicated by the ampersand symbol and borrow the value they refer to. Okay, that's just a pointer. Smart pointers, on the other hand, are data structures that act like a pointer, but also have additional metadata and capabilities. That's what you were referring to. The concept of smart pointers isn't unique to Rust. Smart pointers exist in other languages here. Rust has a variety of smart pointers. You find the standard library that provide functionality beyond the provided and provided by references. Okay, so they have like extra metadata and capabilities. So including reference counting, smart pointer type. Pointer enables you to allow data to have multiple owners by keeping track of number of its owners when no owners remain clean up data. Okay. Smart pointers generally implemented using struct, unlike another struct. Smart pointers implemented the ref and drop traits. The ref trait allows an instance of smart point struct to behave like a reference so that you can write your code to work with either references or smart pointers. Okay, I think, yeah, that's what we were talking about. Given this, that the smart pointer pattern is a general design pattern used frequently in Rust, the chapter 1 covering of this. Many of the libraries have their own smart pointers and you can write your own. The most common smart pointers are the box T, just for allocating values on the heap. Okay, and then RC, generic type, a reference counting pointer that enables multiple ownership. Ref T and ref mut. Okay. Yeah. So I think this is where that I saw that this was I think they introduced this, and also in another going further, they talked more about this box one. You were saying box doesn't really have any additional metadata. Okay, which is why I don't think of it as a real smart pointer. Okay. Yeah, I think this was what I was saying when I was talking about allocation on the heap. Yeah, this one here. Okay. So box is kind of special in the language, okay? Up until the rest of 2018, boxes were unique. Anyways, there was a box keyword used to construct boxes. Okay. Right. Wait, but how come I don't see... Do you realize that I'm actually checking, I'm on the chat on my phone. I don't see you as a viewer here. How are you a ghost here? Okay, that's a different topic, but yeah. Right. Um, so I think that was about boxes when we were. That was I was going off tangent, but yeah, I think this one is yeah. Yeah, that was for us to apparently don't exist. That was for me to understand this part and why this it was like this. Yeah. So when we are dealing with character types like this, then we know very well that um, so the underlying type is what we are indexing on in this case. Yeah. So if it were an emote or something like that, an emoji, we know that it would break. Yeah. So that's the summary of it. And then this is the string literal, the trim. I think trim gives us a string slice. Yep. So string slice, and so happy Monday is a literal we call replace, that gives us a string. And oh no, what's wrong? Okay, it's cool. And my whatever to lowercase, I have no idea what to lowercase gives us, but I would assume that it should be a new string, because why would it why would it give me a reference? No, I don't think expect it would give me a reference. So let me say it's a string, and then we find out what it is. Yeah, I was right. So what does it say? Use this compiler is very rude. It says useless conversion to the same type. Um, so to the same type. Yeah, it's converting to a string slice. Yeah, I was just checking that this is possible. I know it should be a string. Come on. Yeah, okay. So, um, maybe there was this. I think that's probably good for today. That was on strings. I guess there's nothing more on strings, right? Oh, there's string three. Yeah, but I guess that will be tomorrow. A tomorrow thing. Um, so the program I was telling you initially about that I was doing, where is it even? Yeah, this is it. Are you still here? Justus Flugel? Flugel, I guess. Sounds like a German name or something. Yeah, okay. So this is the Rust program that I was building. I think that was like some months ago. Yeah. So yeah, it sounds German because it's German. Yeah, yeah, it is okay. It does sound Flugel. That's why I pronounce it like that. Yeah. So yeah, this is the program that I was doing. So it's like I feel like it's a fairly sized project or something. Yeah, I think I had README right. Yeah, yeah. So this is meant to take my streams, do some work with it, processing, and then upload and do clipping and all those other things with it. Yeah. So I chose this because I wanted to use this to master the Rust language, yeah, and also the ecosystem. So I was basically doing the library here, like the main core library here. Um, I I wanted a gRPC server, which is what I have here. This also runs, by the way. Um, and then yeah, also a CLI, because I wanted to use a CLI tool to interact with it locally. Yeah. So this is the program that we're gonna build. I mean, I'm gonna build when I think when we once we finish this Rust links, then probably I'll get back to it. Yeah. So that's the plan. Yep. Um, yeah. So I guess I'll go to bed now. And it was really fun chatting with you, Justus Flugel. And I need to see your. Ah, yes, I remember you. I remember you. Yeah, I think you were also on one of the lives like some months ago as well. Yep. Yeah. Okay. Nice. So do you use Rust for? Yeah. Yeah. Okay. Then have a good morning, I guess. Yeah. All right. All right, everyone. Then see you tomorrow. Yeah. Bye. See you.